Good morning, everyone. Welcome back from semester break. I think I've got the wrong mic in here. No, should be all right. Hopefully, can you actually hear me? Discord. Yeah, cool. And according to the subtitles on the stream, that tells me that the recording also has audio, so that's good. Uh, Welcome back from semester break. Hope you've had a good one. Obviously, this unit doesn't really have that much assessment early on in semester, so it's been a bit of a cruisy start potentially. I mean, we've had our tutorial work is obviously fairly hectic, particularly the first 4 or 5 tutes. So hopefully some of you use that as a chance to catch up on that tutorial work. And I know that some of you have started on your assignments. I don't have any housekeeping slides today, but just on the topic of the assignment, some people have been telling me that they're unable to create their assignment repository. Look, if that's the case, feel free to let me know, but at the moment I can't fix that. So feel free to just use your tutorial VM3 repository for this assignment. You won't get any penalty, but you should still use that GitHub repository for tutorials VM3 if you cannot use your assignment VM. GitHub Classroom started off really well this semester, but something about their back-end system is meaning most operations just don't work anymore. It means our continued use of GitHub works, but for whatever reason, syncing the assignments and stuff like that have been broken. I blame Josh, as I tend to do. So, you know. But yeah, hopefully people had a good break. I am refreshed and ready to go. And excited to get into the part of the unit that I'm really interested in. Not so much this lecture, but the next one. So we're starting to talk about web service technologies. So actually bringing together some of the stuff that you already know from PHP and the database stuff, and actually making a web application and letting machines communicate with each other, which is effectively the point of these next 2 lectures. So speaking of those, I probably should actually share the screen of those. There we go. Great. So the point of the next 2 lectures is to talk about web services. We're going to go through the basics of these and the sort of what is a web service and why are we talking about them. We're going to talk about something that's effectively going out of fashion, I would say, is a thing called SOAP, all right, service, a way of machines being able to communicate with each other that's largely been replaced in many ways by REST, at least because REST is, as we'll see next week, is a data-oriented sort of framework, and most things these days are just about the transfer of data, whereas SOAP, as we'll see towards the end of this lecture, lets you effectively call functions from other programming languages across networks. They're a way of providing a not necessarily data-oriented interface between our machines, our different services, which is great. So we'll look at SOAP in today's lecture. We'll look at REST next week. But SOAP we won't actually do until week 12 in the tutorials because it's not relevant to the assignments. I'm not going to be getting you to write SOAP code in the assignments. Having said that, we will talk about some SOAP code in the last 10 slides of today. And I'm pretty sure SOAP is on quiz 1. If you're wondering about quiz 1, that's the end of next week. And in next week's lecture, we'll spend 5 to 10 minutes sort of talking about what that quiz is. I can tell you that it's going to have 7 short answer questions. You'll have an hour to do it, and you'll have, and that'll be open over 3 days. You don't have to do it. Well, you probably won't be able to do it in class because I don't believe in in-class tests at the moment until the university makes me do them. So yeah, you'll have plenty of time available to you to study for that one. And it'll be open to do at your leisure in your own time. But more info on quiz 1 next week. So when we're talking about web services here, and particularly the type of web services that we're going to talk about in this lecture, which is SOAP-oriented ones, we're generally referring to this idea of distributed computing where, oh gosh, there's animations. Every week we got to get rid of the animations. I refuse. So the idea here is that with distributed computing, We might have different services from different organizations, even written in completely different languages, different systems, because they're various different ages. So maybe you've got your banks that are, running on COBOL or something from a million years ago, or you've got something running on the latest Node.js random framework that's out there. But you need those things to be able to send data to each other, consume each other's data, and that sort of thing. And so, because we don't want one machine doing all the work, we want to offload, or we want to delegate, or we want to distribute the work to another service, another machine, so that we're not reinventing the wheel, so that we've got multiple points of failure instead of a single point of failure, that sort of thing. So what we have in this modern age, I guess, is the convergence of two different technologies. We've got the fact that the web has come about, right? So distributed computing existed before the web, that you're able to make machines interact with each other, and largely that needed networking. But then with the World Wide Web as we know it now, that's come along and made this even more prevalent and more accessible and more straightforward to do in some regards. So we've got this universal communication method where we've got really well adopted, and that's an understatement, standards with HTTP, these different data transfer standards like XML and JSON. So we've talked a lot about HTTP. We will talk about that more next week. We've mentioned XML and JSON, but we're going to talk about that a lot today. We've got these technologies making up the web as we know it. And then we've got this service-oriented computing that we're used to here. So there's lots of things here that we're not going to go into any detail here around, like remote method invocation and Cobra and things like that. Right? These are slightly more archaic things that, as I said, have been largely replaced by REST. But the idea is that these are these systems that allow machines to communicate, or they might be written in different ways. And so what we've had in the past is we've got all these different services. These might be from different organizations, and the colors in this weird looking diagram are trying to indicate that they might be written in different things. So you might have something that's written in Node. You might have something that is a MySQL server. I'm just trying to write in red on there. Or you might have a PHP server over here, or you might have something that's in ASP.NET, or all these different things. Or it might be a fully Java program, right? So something that you might write. I like that, John. Something that you might write in one of your more traditional software development units instead of a web unit. It might be a Python thing, Python scraper or something, right? And all of these systems would just sort of communicate directly with each other, and we would need bespoke methods for these individual connections. Each one of these different connections is a one-to-one connection that needs to be written in a certain way, that the PHP code needs to somehow communicate with the output of the Java code. And it was sort of a wild, wild west. It's a bit crazy out there, and these things can't communicate properly. Or at least that they can, but it's hard to maintain. There's lots of different ways that these things might communicate. For example, you might have a MySQL package in Node that just directly talks to MySQL, right? So we're going to see that in a future tutorial, in the same way that PHP has a MySQL package, right? It's got some libraries in there. But if you take any one of these pairs of, say, PHP and MySQL, or PHP and Python, there doesn't necessarily exist a communication method, a library for each of these to interop for every single possible communication, every single possible pair that we've got here. And it's not scalable, so it's not flexible, right? So we've talked in the past about what happens when your boss says, I don't want MySQL anymore, and I want to move to a different provider like a Firebase database. That connection all of a sudden is completely irrelevant now and has to be replaced, and might not have the libraries that we need. So this legacy approach where everything's just interconnected and trying to talk directly to each other doesn't necessarily work. And so we've alluded to, in I think it was week 2, a service-oriented architecture, where yes, we've still got our different services that are written in different languages or frameworks or whatever, right? Our PHP one, our Node.js one, maybe we've got a Java program, over here is our Python scraper. But a service-oriented architecture like this would have a way of communicating between these that we'll talk about in a moment, like a thing called SOAP. But also we could use something like REST for this sort of bus, this way of them interoperating together. This will become clearer as we get through the slides, with any luck. So the idea here is that if we're designing a distributed application that uses a set of services over the internet, we need a way for these services, an architecture that lets these services communicate with each other. This whole point of talking about service-oriented architecture, at least from what we're talking about today, is largely about how do we make these things communicate. And in a service-oriented architecture, like in the diagram here, and we'll show a few more diagrams of this, having these different services being able to communicate through a protocol like SOAP means that everything is platform independent. We'll see that it doesn't matter if PHP is talking to something over here, because all it is actually PHP is talking to a SOAP protocol, and Node.js is talking to a SOAP protocol or a REST protocol. So then you only have to have that support for PHP plus SOAP and Node.js plus SOAP and Java plus SOAP. You don't need to have every single pair of these that want to talk to each other. So there's only one sort of way of doing that, and it's platform independent because this all runs over the network, over the internet, as we'll see. These services are loosely coupled and can be swapped out. They can be reused. They can be integrated in different ways to meet changing needs, and they can be extended so that services could be offered over the internet, or you could switch out a service with a better service, that sort of thing. And overall, because there's less code to maintain, there's less implementation cost. So a bit of an idea of distributed computing and a web application that brings together multiple services. Here's an example of, it's an old screenshot here, but Google Flights, or Google Travel, I think they might call it as well. So here, Google isn't the thing that that works out. My phone's just going off because I said the word Google 3 times. Google isn't the thing that works out necessarily what are all the current flights for Jetstar and Rex and all that sort of thing. Instead, it talks to different services to get this information, and it collates them, it mashes them up into this web application. So the web application is mostly just how do we search it and how do we sort these by the best possible trick based upon whatever their algorithm is for that. But in terms of where the data comes from, and maybe going away and calculating the emissions and that sort of thing, all this information comes from different service providers and they're brought together. In order for this to work though, the Jetstar platform, the Rex platform, all these things that provide data to Google and to other travel agencies and that sort of thing, they need a common data format in order to do that. Otherwise, Google has to write, a function for getting all the Jetstar flights, and then has to write a different function for all the Rex ones. And then a new provider or a new airline comes along and they have to write another provider for that. Instead, there would be published services on how what sort of format is expected. What's the standard format for flight data that Google then can use to consume all of this and produce its app? So that's a fairly straightforward example of a web application that uses effectively distributed computing here. So in a service-oriented architecture, we access our resources, which is usually data, but resources might also be, functionality or some kind of software. It could be anything. And so we have services that expose these, and we communicate with those through a standard communication method, right? So the way that we access our services is through a standard way of communicating. And we'll see an example of that today. Then developers, like what we saw on the previous slide, Google and even you with your, even the assignment one where you're using APIs, web APIs, that's a developer that's integrating and building applications out of these different services, as long as they're provided externally. So as long as these services have a standard way of communicating and we have access to them, we can build applications out of these services. And that's going to be largely the point of what we look at through the rest of this unit. So we've talked a lot about standards existing here. And so several standards exist in the service-oriented architecture for, when a web service is made, we need a way of telling the consumers of those services what is available to them. So to use an analogy that you guys should already know is when you're working with a library or an API, say you're writing something in the Unity game engine, right? A pretty large piece of software, and they've got all these functions and code that you can use. There's a way of describing all those in terms of an API documentation for you, the developer. So it's the documentation that you students never read. That is a way of describing the Unity API. The same needs to exist for a service-oriented architecture, or a web service, I should say. There needs to be a thing that lets the consumers know what are all the endpoints that we can use here. What are the parameters that we need to send when we're using different endpoints? So there is a standard. There's a couple of different standards. We're going to look at one today for describing web services. Again, slightly going out of fashion because it's related directly to SOAP, but registering services and making them available in a way that you can look them up and find them and get those descriptions to then actually use them. There's a protocol or a standard for that. And then the actual important part, the actual doing part of once you've got access to a service, you know what data to send to the service through what the description is here. How do you actually invoke the service? So how do you tell the Pokemon service to give me a list of all the ground type Pokemon? Or how do I get the service that books flights to book a flight for me? How do you actually run the code for that? And so there's a standard that's written for that as well. And we'll talk about how all those work. Here's another diagram, though, I guess, that's similar to that one that I showed before, where we sort of had the bus sort of approach, where we've got all our different services and they need to communicate. So say you've got a web application here overall, this shopping application, and there's three big parts of a shopping application that you need to have working, right? So this is the server of the application, not the end user's client. So the end user is, say it's me who's wanting to buy things from the shop, right? I'm here on this computer, and I would probably be communicating with the retail web server, right? This is the web service for it. Or maybe the boss of the company who wears a fancy hat, right? They're communicating with the admin panel for it, right? But they're the only things that the boss and the consumer interact with. They don't interact with the larger system as a whole. They interact with the web service. So they're looking at the website, and those go into our shopping application, which then distributes this out to and delegates the jobs out to somewhere else. All right. So say it's for actually creating the payment, right? So instead of making the user's credit card go directly to the credit card service, it might go through the shopping application, and then using our SOAP protocol that we'll talk about in a second, that communicates with the bank. But the bank is more complicated than just a single server. We go through this edge node, as we like to call them, where we can say where there's some kind of service for checking credit cards. There might be other services that are provided by the bank, but the only one that we care about is the credit card check. So the bank sees an incoming request to say, okay, we need to check the credit card, all this sort of stuff, and then it bounces around their million servers that make the bank work, and it comes back out with a yes or a no. Similarly, for all the logistics of, okay, we've got an order, how do we actually, all the shopping application really wants from this is a tracking number to give back to the user. So when we're shipping it, the system might do a whole heap of bouncing around inside their internal system, but the idea is it would spit out an order number. We've got an interface here where we have simple inputs, simple outputs, hiding, if you like, or being a front for a larger, more complicated system. And to make this all, why isn't this all on one server? is that we don't want to have to reinvent the logistics company every time we make a crappy little internet store. We want the bank to handle all of its things. And the other thing here is we notice these strange little words here. These are the server-side architectures that might be going on for the bank, the logistics company, and the supplier, and that sort of thing. That our shopping list application might be written in the absolute latest Node.js beautiful framework that everyone's going on about, that Fireship's made a video about, but the bank is still using something that's Java. This one's using DCOM, whatever that is. All these sort of different things, but they're all hidden behind their interfaces. So here, once again, is that SOAP interface, that protocol. That's all the shopping list application needs to, the shopping application needs to know. It doesn't need to know about the different banks and their different ways of doing its check. All it needs is to be able to get to the edge point here. Okay. Does that make some level of sense of what service-oriented architecture is attempting to do here? Cool. And I think it's fair to say that it's still entirely possible that this could be REST instead of SOAP. But the slides that these are adapted from are from 2006, when SOAP was still the greatest thing since sliced bread. So between one of the things that we said is needed here is, if we just go back to our different services, so we've got the protocols for, or the standards for describing those services, so that we can see what services are provided by the bank, and they would have them registered and would be able to, be able to see that as a machine and also as a human. You'll keep on calling me. I need to leave me alone. We need a way of invoking those services, and that's what SOAP gives us here. But probably what's not mentioned on this slide, and should be, is something for data communication, right? So standard ways of how does this data go backwards and forths. I guess that's part of how we invoke the services, of how do we, in a standard way, tell the different services what we want them to do, and how do we, in a standard way, understand the resulting data as well. Right, so the SOAP, this communication here, there's some data going backwards and forwards in this communication, and that's what this section of the lecture is about XML and JSON. So these are formats for representing data to share among heterogeneous peers, which is just a fancy word for saying different, right? So as we know, those different peers in that example of the bank, the logistics company, the supplier, they're all different, they're written in different things, but we needed a standard way of getting them to communicate. And at least in my tutorials, we've talked about how JSON and XML are really handy for this, right? Because they're in a text format, which can still be compressed into binary and that sort of thing if you really want to, but as in it can still be made into a compressed format, because as we know, if it's all as text, that's bigger than if it was a compressed file. So it's in a text format, so all these machines need to really be able to do is send text to each other over the protocol. That's fine. And these JSON and XML are language independent. And what we find is that in any language that is worth its salt that is actually used in this, so C#, Java, JavaScript, PHP, Node, all that stuff, they all have libraries for reading and writing JSON and XML. And a few others, but these are the two that we're going to talk about today. So they're largely used for data exchange because of that interoperability where those libraries exist on both ends. But they can also be used for storage. They're not the most efficient for storage because when they're stored at rest, then you have to, when they're in the database or on file or whatever, you have to decode them and turn them back into objects. There are... Every week still we get a JSON video. We love it. They're not amazing for data storage. They might be useful for smaller applications, but you wouldn't store an entire database in JSON. You would use something that's designed for keeping data at rest in a cached way. That's not to say that it's not used underneath the hood on some systems. So Firebase, for example, effectively is storing your data in a JSON approach in its database. They can be used for machine-to-machine and human-to-machine communication. So while we've been talking about, and we'll be talking about machine-to-machine communication here today, it's really easy to look at them while they're in transport, or debug them out when you've got the data back. And so they're generally human readable. I didn't write these where it says XML is more human readable. I don't necessarily agree with that. I think they have their pros and cons for being readable versus not readable. I guess, XML has slightly less syntax to it and is a lot more verbose, but being more verbose can make it difficult for a human to read quickly, whereas JSON, I think, if you use it enough, is fairly straightforward. Does anyone have any opinions of that in the chat? Of like, which one do you think's easier to read? Or maybe we'll wait until we actually look at the examples of these. I don't know. We should do a poll of what's your favorite XML or JSON. I think they're both as good and bad as each other, is my personal opinion, but I'm interested to know what the chat thinks. Don't know enough about XML. We'll see it in a second, and we'll ask this question again in a moment. So XML, hopefully you've seen it in the past. Some of you have seen it as a way of storing, of describing your user interfaces in Android. Some of you have seen it as a way of describing user interfaces in Windows Foundation presentation, whatever it's called. Those forms that I don't use because I don't write Windows apps. And you've seen it in HTML as well. All this really is because XML is great at providing a tree structure of nodes with different parameters on them. And so those, when they get read in, those get turned back into objects anyway, that then get turned into your Windows forms or your HTML page that your browser renders. There's nothing stopping us from having a HTML page described in JSON or YAML. Gosh, that's an idea. Why has no one done JSON HTML, like their own version of that? There's probably a reason, but I might just quit this lecture now and go be rich. It's just a way of storing that data. So effectively, any data can be translated into XML, including ones that have complex relationships between the objects. We can send it over HTTP very easily, and any application can handle XML in a good way. Yeah, sure. Pretty much all of this can be said about JSON as well. So for those of you who haven't seen much XML, here's what it sort of looks like. If this looks like HTML to you, then you would be almost right in that HTML is a form of XML. So the way that we're working here with XML is that we have tags, just in the same way as we have HTML tags, because HTML tags are actually XML tags. And they have a start and an end, usually, right? So we can see that with the person tag, and that means everything between the start and the end tag is part of that object or that particular tag. However, there are some tags like this self-closing tag, which if they don't have anything inside them, including they don't even have to have a parameter, which we'll get into a second, or an attribute, you can just have tags like this, just to say that there is an email element in there. We can have text nodes in between tags, so that's the easiest way of just having free text inside. But if we want to have different parameters that are named as key value pairs, then would have attributes as well, which provide a little bit more flexibility than free text, but they get a little bit more limited in what you can write inside them without messing up your syntax. So effectively, through this hierarchy and through the use of text content and attributes, we're able to basically structure any data here. You could think of this as a person class that has 3 fields for name, phone, and email. But depending on what you actually got here, it might be that maybe it's a list of phone numbers, in which case you need a phones tag to represent a list of things. Okay, so you still have to parse this and then turn this back into a PHP class or a C# class or whatever. But in general, objects, primitives, and arrays / lists can all be represented here. and we can go a little bit more complex. If you've ever seen a Unity object ever get serialized, you might see that the actual type, the matching C# type with its namespace and stuff like that might be done as an attribute, right? Depending on what your XML parser is set up to do. So yeah, if you've seen HTML before, which I hope you have, you can see that they use the same syntax. But HTML is a display format, really. It's a structure of a web page, and people do overuse it to be able to get all the formatting they need rather than using CSS. But it's certainly more about how do we display this data in a browser. It loses, pardon me, it's got the semantics for what a web browser needs for structuring a page and for screen readers to understand a page and that sort of thing, for how a document should look like. But it loses the structure that can be used for making a class from it, right? So an XML actually describes the data in terms of its proper structure, not how it actually appears on the page, right? So it's a data description format, whereas HTML is the display format. Hopefully you can get the difference between those. What you might not have seen in XML before, though, is, okay, we know that we can describe data like this. What sort of formats can we use to make sure that this is valid data, right? So when we're sending this over the internet, and we're receiving it, I should say, how do we know that this is coming back in a valid way, that it hasn't been messed up, so that our program doesn't crash? And how do we get a sensible error message if we do get incorrect data sent to us? Because maybe this has been typed out by a user, or it's been generated by another program that's written by a 4-year-old, and so it doesn't know how to be, it's not generated properly. What we can do is we can have an XML document can have a document type definition. So XML documents can look like the way they do, but we would hope that a document is well formed for a start, in that we don't have any extra greater than signs or slashes or things lying around, so that the programs can actually read the tags and the attributes without any issue. But then there's a second stage here, is it actually valid or not? So does the XML represent an object that we can actually use in our program? And it's this validation that's really important. And so a DTD is able to describe this for us. It's a little bit scary syntax, and don't worry, you won't be using it in the class, but I want you to know that this exists. Is that with a DTD, we're able to say, okay, we expect there to be a type called company, an element called company, for example, and it needs to have certain tags within it, or certain elements within it. And we can describe these with this slightly crazy DTD syntax. But what's going on here is we're saying that a company needs to have a number of person objects and product objects inside it. Okay. Then we describe what a person object has in it and what a product object has in it. So a person, we might say this has to have a social security number, a name, blah, blah, blah. A product needs to have an ID, a name, and a description as tags within them. And then, of course, we actually describe what each of those tags should have within those. And a name is being reused from up there. So that's how we can enforce a structure, but we can also say, there needs to be exactly 1, or there needs to be 0 or more, which is really useful for, being able to correctly turn this back into an object. That if our program's expecting a list of person objects and a list of products, then we can actually handle that. Whereas if our program isn't expecting a list of SSNs, social security numbers, but it is expecting that to be a field on a person, we can sort of encode that into our DTD. And these can be generated from C# classes, PHP classes, that sort of thing. These can also be generated from those wonderful UML diagrams that you guys do. Who loves those? It's my favorite. Haven't done a UML diagram in years, just FYI. What this is saying on this slide is also that the social security element contains text data. Don't know why they call it PC data. There's probably an acronym there. So that means that this object would be run through it, and it would be considered valid. Obviously, this is fake data. But if a person was missing an SSN, for example, our XML parsing program would be able to use the DTT and it would be able to say, this isn't a valid document and here's why. Person in element 0, person number 0 is missing a social security number. And it would spit that error out to you. Kind of like a compiler, yeah. But it's a parser. So that's XML. Once we've got our data in XML that's given to us over the network, or we're reading it from a file or whatever, we have some different tools available to us. The only one that we will play with, and it's later on in semester when we get to web scraping, is a thing called XPath. We're not going to do slides on XPath now. We will talk about it later on in the context of web scraping, right? So you can imagine that you get your HTML page from somewhere else that isn't giving you an API. It's like the Kohl's website and you want to list all their products, but they haven't given you an API because they don't want to give that to you. You have to do it yourself. You can use a tool like XPath to traverse that XML structure and read through and find all the objects, and doing that in a smart way. It's kind of like jQuery's, not jQuery, it's probably closer to the rules in CSS, which use XPath. I don't know if it uses exactly XPath, but it uses the same sort of thing. So you know how in CSS you're able to select certain elements, right? You're able to say, find me all the paragraph tags, or only find me the last anchor element or link element in a page, something like that, or find me a div tag that has a certain class. You can use XPath to do the same sort of thing, to say, okay, extract all this information, use those, and then use that for whatever, right? So XPath and the CSS selectors, as we call them, that's it, selectors, are very similar, possibly even identical, I'm not sure. Haven't used XPath enough. Then once we've got structured XML data, we can query that as well. Lost the stream? Has anyone else lost the stream? I'll just restart this. No, it says... Is that because I'm still trying to screen share? How about now? You might have clicked on the other thing, because I think I had both the screen share and the video going. Yeah. My bad. So we can query XML data, and we can also traverse it in a fancy way as well. These things exist for being able to handle XML, but we won't discuss those last two. We will be talking about XPath in the context of web scraping, which I think is like week 11 or 12. Moving on to JSON instead now. So don't let the 90s HTML website fool you. JSON is very useful and is used by a large chunk of the internet, I guess you could say. It's the backbone of REST as we see it, but it's absolutely used as a data interchange language. So do make sure you try and understand JSON, because even beyond this unit, I'm certain you'll be using JSON in the future. I can put money on that, I reckon. So JSON stands for JavaScript Object Notation. But don't let that fool you in thinking that this only works for JavaScript applications. It works with JavaScript beautifully, to the point where, with some exceptions, something that was a JSON file, suddenly you could put that into a variable in JavaScript verbatim, and it would just work. So the syntax here will work with JavaScript with some exceptions, I think, but because a JSON can vary a little bit. But overall, this could just be literally pasted into a JavaScript file. So it doesn't have namespaces, which XML does. We didn't talk about that. XML goes a lot deeper than JSON does, because it's designed to be a little bit more heavyweight and handles namespaces and things like that. It doesn't have attributes, but it kind of does because it's got fields instead. Everything's an attribute. It's just, yeah, slightly more straightforward to work with. It does support schemas. We'll show you that in a second. But the idea here is we can see that a JavaScript object does start and end with a curly brace. Then we have key value pairs throughout everything. Keys or fields, but I like to refer to them as keys at least. So we have a key for first name, and then we say what the value is, a key and a value, a key and a value. We can see that our values can get a bit of a type to them by omitting the quotes, so it suddenly becomes an integer, or a number, I should say. We can have objects within objects, just like XML can. It does, in my opinion, a slightly better job at arrays than XML. So you can have an array syntax by doing square brackets, and then that array can contain whatever we want. It could be an array of objects. Everything in an array doesn't have to be the same. So it might be that this array contains a number, some text, and then an object and another object. There's no type checking here. There's no type safety. Same as same as JavaScript. It's the same deal. But we can see that an object is fairly straightforward to represent here. So now I can ask the question: who thinks what's everyone's favorite, XML or JSON? Which one's easier to read? I won't judge you. John says JSON. Jane says JSON. Like it. Hank says JSON with caps and exclamation mark. I love JSON too. Excellent. Maybe all the people who like XML have been quiet because it's kind of obvious that I know which one is my favorite. XML absolutely has its place. Markdown is fine. It's a slightly different concept. I like Markdown, but it's not really a data transfer thing in that it doesn't allow for the right kind of structure that you can't. I know this was probably a joke still, but I'll go into it anyway, that in general, you can't encode every single type of data easily in Markdown in a consistent way. But Markdown is beautiful. I love it, and I am thinking about changing my tutorials to be written using Markdown instead one day. But you all should be learning Markdown for your GitHub README files anyway. All right. So data types here in JSON are pretty straightforward. You can store strings, you can store numbers, you can store sub-objects, you can store things as an array, you can store booleans, and you can put nulls in there as well. And as I said, there's composition of objects, so you can have an array of objects, you can have an array of arrays, all that sort of thing. It's a fairly straightforward structure. Okay. I did say that JSON does support schemas. So there is a schema here that lets us say, ironically, a schema file does have its own schema of how they should be laid out. But basically, without going into too much detail here for a schema, is you can say for a given field or whatever, like a person object, we can say its type has to be an object. So it means it'll be looking for curly braces, and it'll be looking for certain properties, which are the same as keys or fields, but they've decided to call them properties. That's probably the correct term. And so then this is a list, sorry, it's not a list, but it's a set of properties that we say this thing has to have, and then we can put some extra metadata on them to say the first name must be a type. And so some of this gets used by the parser. And yeah, maybe if we've got an integer, we can put some constraints on that as well. But then you might be wondering, okay, so why is there a title called person that isn't actually used on anything? Why is there a description? Because actually the schema can be used for generating forms and providing a little bit more extra information. So if we know that we're trying to get input from a user that needs to eventually be put into this JSON object, we can provide them a form that does exactly this. You could imagine that you could make a form that has 3 input fields, the first name, last name, and age, and one is a text field, another one's a text field. It has this as an extra label next to it to give the user instructions. This one doesn't let the user provide numbers that are less than 0, so it's got client-side validation. There are tools out there that I'm happy to share with you later that will generate forms from a schema, and we'll do that for XML as well. A really useful thing to be able to generate forms rather than writing your own forms. That's kind of when you level up just a little bit as a developer, is you're not writing your own forms anymore, you're getting them from a schema, but it's not always possible. Okay, I would give a break, but we started 8 minutes late and I want to get to the end of this. So instead, we more than likely might finish early. We'll see how we go, but we're going to talk about web services now. So earlier on, at the start of the lecture, we showed this crazy looking diagram that looks like modern art of all these different applications that use various programming languages. They're heterogeneous, and they're, trying to make these communicate with each other is a pain. How do you actually do that? So we need web services in order to do this. So we're sort of going back a step a little bit here and talking about them at a high level. But a web service is a software system that, using URIs, which is the fancier way of talking about URLs, so universal resource identifier. They've got interfaces that we can describe using XML. So the actual working group definition for a web service, I think even to this day, still says XML, but then stuff like REST doesn't necessarily use XML. We should be able to see that this is lining up to what we're talking about with SOAP, that they can be discovered by other software systems. And then you can invoke those using whatever the predefined descriptions are, right? So there's some way of interacting with these web services by its prescribed definition. That's its interface, its list of things that you can do with that web service. And we send data to them with XML, and we get data back. A web service should be able to self-describe itself as well. So you should be able to say, okay, tell me web service all the things that you can do. Like, tell me the list of functions that you've got. So that was the wordy standards way of talking about it. In simple terms, a web service is something that's accessible over a network to our clients. Remember, the client here might be a web browser, or it might be what? While I take a sip of Red Bull here, what else might the client be? Because we're so used to, in our other units, thinking about it as a client server, and it is still technically client server, but it's not just our users in their web browser. It might be a web app itself. So what do you mean by that one, Cole? Just so I can be clear. Like, what might that be written in? Because I think you're right, but it might be just my way of interpreting what you mean by web app. So, it might be a PHP server of your own. This might be a server talking to another server. But in that communication, the server becomes a client of the other server, if that makes sense. Just like we were doing in the week 6 tutorial, where your PHP code using Guzzle is the client interacting with the web service. Or the PHP SOAP client interacting with the web service. Right, so our server can become the client in this interaction. But yeah, it might be browsers, it might also be mobile apps as well, that sort of thing. So they connect through the network. And what we've always sort of seen as this diagram is the client server, and there's the network in between. But what we've got here for this diagram is the introduction of the web service, the thing that takes our standard SOAP commands and forwards that onto the application. Or it takes our REST commands and it forwards that onto the actual application behind the scenes. So it's a capability or a service or whatever that is exposed over the network with interoperable standards. We have payloads that we send through as XML documents or JSON. It's transported in some way over either HTTP or some other protocol like SOAP, which still uses HTTP underneath the hood. And they can be used by any programming language on either side. So this is all rehashing what we talked about in the first 20 minutes of the lecture, I guess. Let me just check. Yep, we've already said all of this. And I just wanted to clarify, because some people get a bit confused, but Cole used the word kind of perfectly here, I think, as our web application. That's our user to program interaction. That's the thing that the user's seeing. And on the other side is this web service, which is for program to program interaction. It's where, the web application might be Google Flights, right? But the web services are communicating between Google and the flight service, and Google and the emissions service, and all that sort of thing. So there's web services that a web application can actually use. So the types of web service that we've got here is we've got our SOAP service and our REST service. The difference here that will become clearer as we now talk about SOAP and REST will be next week, is that SOAP is about running or invoking programs and code over the network, whereas REST is much more data oriented or resource oriented, right? So when we talk about CRUD, where we're creating documents, we're reading documents, we're updating them, we're deleting them, they're largely what you're supposed to be doing with REST, but REST can be used for invoking code as well. There's nothing stopping you doing that, but as a general rule, RESTful services are much more resource oriented, whereas SOAP is about running applications, so checking a credit card, purchasing a flight, something like that. So invoking code. So web services are considered good if they're able to be self-describing. That is a way of being able to list out all the endpoints, for example, or being able to see the interface easily. They're discoverable, that you're listed somewhere and people actually use it. They're coarse-grained, that they provide high-level access to the system, and they're asynchronous, that they can run over time. That they can, they can, I don't know exactly why asynchronous is exactly here, but it's more that, you can make a request and the data can come back, not necessarily immediately. So let's talk about SOAP. SOAP stands for Simple Object Access Protocol, and it does use XML to a large and painful amount, as we'll see in a minute. So when we go all the way back to that diagram of the shopping application, and it needed to talk to the bank, it needed to talk to the supplier and stuff like that, we saw SOAP there. We saw those arrows. Those arrows, the payload that's going on there is XML based for SOAP. When we're using SOAP sends a message to an application, and we also get data back from that application in what's called a SOAP message that largely has 3 elements to it. So this is the equivalent of how HTML has headers, and it has the body component that you actually get the data back from, or where you send some data to the server. So it's actually largely the same. It's got a thing called an envelope, a header, and a body. Let's see them in a diagram. We'll just jump straight to it. Is a SOAP envelope is an XML tag for SOAP envelope. Pretty straightforward. And then it's got a header tag and a body tag. And so when you generate this in your PHP code or whatever, and you send it to another server that might be written in Java, it's able to read all of this, and it extracts the envelope, and it extracts the header and the body from it, and is able to use that with its SOAP protocol on its end. Okay, and so what goes in the header is some communication info. In the body comes the XML document of maybe what we want to do, that describes what we want to do. So the header we won't talk too much about, but that is the same as our HTTP headers. That's where we might have our authentication protocol in there. It might have, no, it wouldn't have cookies. It probably really only has the session key. There might be something else that it has in there, but this is the best example I've got. Then the body actually contains a way of describing the function that you want to invoke on the other server. So it might be that the other server is a list of products with prices and that sort of thing. So we might say, I want to call the get price function on whatever that application is. So we describe it as get price, and we have a parameter here of which product do we want to get the price for. We encode that as XML and chuck it in the body. And so that gets sent through to the server for that. So that was our SOAP protocol, and it's written in XML. What we'll come to in the next few slides is, okay, how do we know that there's a get price function that we can call, and we know that it's got an item as a parameter? What describes that? How do we know the interface for this server? How do we know what all the other possible functions are? We use a thing called WSDL for that describes the web service overall. And then how do we know that this price serving application even exists? We get that through a UDDI. So all of these fancy acronyms, we're going to keep on coming back to these over the next few slides. So there's our SOAP envelope that has its header and its body. Pretty straightforward little protocol there. Similar enough to HTML, but yeah, this is us for making a request. Something else to mention here is that this gets generated for you. So, no one wants to type out an XML file like this. The SOAP library in PHP and the SOAP library for whatever you're writing this in JavaScript, Java or whatever it is, can generate this really easily for you. You say, I want to call the function getPrice with apples in it, and it will generate this for you. It'll even generate it from you, we'll see it in the next slide, I think, from actual code. So what you end up writing on your server is, pretty standard code where you're calling functions and passing through parameters and that sort of thing. And so every time you make one of those function calls, it gets turned into a SOAP message for you. We'll see what that looks like in a second, and you'll see it in the tutes when you get to playing with SOAP in week 12. So that was SOAP encoding, where we take it's basically a set of rules in order to take a function call or whatever it is and turn it into XML format. So that envelope that we just saw, as I said, it's generated by the programming language for all of the requests and for also the data coming back. Let's see what I actually mean by that. Is that you might write some code that has the clock service, and you want to call a function called getTime, and whatever your language is, this has got named parameters, apparently. It lets us, we put the parameter into the code. This gets translated, into a SOAP envelope. I haven't shown the whole thing here, I've just shown you the body. But here's what it looks like. It goes, okay, the getTime function is there, and the parameter called location, which is of type string, has this value. And so that gets sent off to the other server as a way of calling that function on the other server in the other programming language. Does that make sense, that we're able to effectively do, I don't want to call it remote code execution, but I guess to some degree it is. We are absolutely executing code on the other server because it's being translated into a SOAP request that the other server's getting, and could be in another language. Hopefully that makes some level of sense to people. Yeah, don't need to know the exact rules of how it's generated, but yeah, sure, I like that description, Cole. It's good. So, as I said, how do we know that a service has that getPrice function with an item parameter? Or how do we know that how do we know that there is a clock service that has a getTime parameter? And how do we know that it accepts a parameter called location and that the type of that has to be a string? Well, we can generate that from all the functions that we want to expose. We've got our class there, our clock service, and it's got its functions that we've all defined in the PHP code or in the Java code. We don't want to have to write a big description for everyone else. We want to generate that in the same way that you can generate documentation for your own code as well. You can have I don't know the name of any document generators off the top of my head now, but you can take your code that might have comments in it and has all that structure, and you press a button and it generates API documentation for you. Same sort of deal here with WSDL, is that we want to generate an XML document that describes our web service. We don't need to worry too much about the details of this. You'll get to see one in action in week 12. But we have a part of the document that describes what are all the methods, what are their messages that they accept, and what are the parameters they accept. And then how do we implement that? So where is the location of this? What's the URI for this? What protocols do we need to use? What port is it? That sort of thing. So we can generate all of this for us quite easily. So here's what a WSDL for a service for, what is it? This is Magic 8 Ball. Yeah, a Magic 8 Ball service description, I believe. Let me double check that. Yep. So our service has a service name of 8 Ball. It's got a single function, as far as I can tell, yep, that is called get an answer. It has an input parameter. It could have more than one input parameter here, but it's only got one, of asking it a question, and it's able to output a response. So it's about as simple as an API gets. A single function that has a single input and a single output. We describe those, so those line up here of what do we mean when we say a get answer request and a get answer response. That's where we might describe what are the parameters to that. So we might have a question type and an answer type, and then that's how we might describe them as question types are strings, answer types are strings as well. You can sort of see how verbose this is for just a really simple API. But this is all needed so that both ends of we'll call it the consensual remote code execution that Cole called it here, both sides know all of the ground rules, knows all of the safe words of how this should work on both ends, of how do we call the functions, what does the data look like coming back, so then we don't have any errors on either side. So this is a description of our interface in WSDL format. We don't need to worry too much about how this is actually structured, but you can see how it is actually structured here fairly straightforwardly. They're referring to port types here as what are the actual functions that you might call, not actual ports. And so yeah, if you thought this was a whole heap of stuff, there's actually more to this file than that, in that they still have to describe where do you get to it, on what port, what's the URI to it, all this sort of thing, what are the bindings. So it is a little bit more complicated than what the previous slide tries to show. And so you've got that way of being able to ask the SOAP service, who are you, what do you do, what are all your functions that you have available to me, but then how do you publish that? How do you provide that to other people? We won't go into too much detail about this, but there's the UDDI protocol here. Once again, it's an XML-based specification to describe different web services over the internet. So being able to access those and find the WSDLs for them. So what do we actually mean by that? And this is something that we don't really see much of anymore. It's a little bit, how to say, we could call it overkill. It might be a little bit too much, but it's useful for those really high risk environments, I guess, like banks and that sort of thing. So things that might still actually use SOAP. When we talk about REST next week, none of this registry is needed, but there are still useful tools like Rapid API and other libraries that provide a way of finding APIs, and there are certainly ways of describing RESTful APIs to know what all the endpoints are. But yeah, in SOAP, with the UDDI registry, that's a third party here. The client will say, okay, what's the service that we want? The registry goes, okay, I know what you're talking about there. It gets the WSDL document and it gives the client access to that WSDL document, right? That list of how to use the service and also where is the service. You can kind of think of this as, oh, you guys are too young for this, the yellow pages of web services, or the, oh, I don't know, the friends list. I don't know what you guys use that would do this. No one uses phones. How do you search for people? I don't know. Well, yeah, the yellow pages is the phone book, sure. Yeah, I mean, but you still don't. No one uses actual phone books. They're so much smaller. But yes, the yellow pages, the phone book. That's the analogy that we'll stick with for a few more years. I don't know. I think you are too young for phone books. I'm sure of it. I mean, you probably know what they are. Definitely know what they are. But how can you say you've used one in the last like 5 to 10 years? So that tells me that when I do this lecture in 10 years from now, no one will know what a phone book is at all. Yeah, when you were young. So now there's like, that means your children, though, they're not going to use a phone book. And when they come to my lecture, they'll be like, what? Yeah. So I'm going to have to work on that analogy for the future. That's fine. But also UDDIs probably won't exist either. Anyway, the WSDL document that describes how the whole service works and where it is and that sort of thing is provided to the client. The client has access to that. Then the client uses that to interact with the SOAP service itself. So this is the actual web service. This is the bank, or this is the supplier, or the Pokemon website, or whatever it is. So the communication between the client and the SOAP server can go on. Used to weave them. Amazing. So the client uses the WSDL in order to send a SOAP message in the right format, and the web service, it knows, of course, the WSDL because it wrote it. It returns the data in a SOAP message format, and both sides are able to understand what's going on because they both know what's in the WSDL document. So suddenly this client and this web service that are written in completely different programming languages potentially can communicate. Here's a diagram that I hate that says the same thing, and I'll leave that for your own time to have a look at. But it's got that UDDI registry in there. It's got your requester, your client in there. It's got the SOAP interface in here in the web services platform. But if you want to really simplify both of those diagrams, we've got our web service registry, which the person who writes the service publishes it to there, publishes their WSDL to there. Our web service consumer uses the registry to find it, and then it talks directly to the web service for the actual binding and invoking, as we call it. So this is just fancy words for saying actually connecting to the server, making those message requests, reading the message responses. And so the web service consumer obviously talks directly to the web service provider. But that web service registry is used in between in order to get that communication started. So now we're going to venture into the last part here, which will be useful when we go to week 12 and actually implement SOAP. But just so you can see some examples of what the code looks like, and then we'll be able to finish early, which is neat, unless people have things they want to talk about or things they want me to show, but we should be doing okay for time with any luck. So it does say, 11 slides today, sure. So we're going to show you how to use SOAP in PHP, but hopefully the point is that you've gotten by now, because I've said it a million times, is that there is a SOAP client in Java, there's SOAP client in C# and that sort of thing. So you can create SOAP server and SOAP client objects. You don't have to use WSDL mode for describing everything, but we will, I believe, in the tutes. You might like to set some settings in how to set this up. And you do also have to enable this SOAP package inside PHP. So there's a little bit of settings that you can do in the PHP INI file. We haven't actually touched INI files for PHP before, but this is where we can set some global settings for our entire PHP application. So we have to install the SOAP package. We need to set some. We can enable the SOAP extension, and then we need to restart Apache because we've made config changes to Apache/PHP. Our SOAP client, right? So the thing that's consuming the web service, that needs to have the URI of where is the SOAP server attached to it. So the URI of how to connect to the server. And in your week 12 tutorial, you'll have a client on VM2, I think it is, and a server on VM1, or it might be the other way around, talking to each other, which is going to be great. So here's an example of a service that you might set up in PHP. So in this example, what is it? Let me just double check. Oh yeah, sorry. Brain suddenly switched off there. It is the ugly duckling. That is true. The brain switched off there because this is Java code. What's Java code doing in our web unit? So the point of this class here, written in Java, is that we could be executing any Java code that we really want here. It could be, I don't know what people use Java for anymore that they couldn't use somewhere else, but sure. Maybe there's something beautiful in here, or maybe it's maybe you can do some machine learning. I don't know. Anyway, it's some some Java code that just returns some data. So we've got a function called hello. It returns a string, and it has a parameter called txt. Right. So these are the bits of Java, or if you've done C# before, this should look basically like C# to you. There's enough syntax here that this is indistinguishable from C#, I think. The text parameter has a string type. So string goes in, string goes out. Our actual Java code doesn't do much, does it? It just concatenates a string and sends it back. It's a hello world message. So and it's in a class called hello service. So that's a pretty standard Java class that doesn't do much. What you might have noticed though, if you're a Java programmer, is that we've got a couple of, I don't know what they call them in Java, but I assume they might be called attributes or annotations or something, where we can take our class and we can add some extra metadata about that class using an @ symbol. So we want to say that this hello service class is a web service for SOAP, and this is the name that it should go by. It's stateless, which must mean something for SOAP here, in that it doesn't need to keep any data in between messages here. It's just a static thing. We've got an attribute here for every method that we want to expose via the SOAP protocol. So we've got one here called hello, and this is useful that if our code is written with certain function names, but we want to keep a standard interface to the outside world, we can have a different name for the method to the actual one in the actual code. So this is the one that the client will use, and so is this. The client will use this, and it just so happens that these line up perfectly, but they don't have to, yeah? And we've got another parameter, another attribute here for web parameter to say what's the name or the label that the client will use when trying to enter in the text. And this one is different. That we've got, whatever our favorite variable name in Java is, but then for the SOAP client that's using this code, they will forever refer to it as a message. Thanks, Han. Glad that you know that it's annotation. In C#, yeah, I'm pretty sure we call them attributes. The same would exist in C# as well for the SOAP client there. So yeah, everything that's in these annotations is for what the client can use. And so this is what gets generated from that 4-line Java file is, here's the WSDL for that, right? It says, here's how you access it. here's our hello service. Here's the messages for sending messages to the function and for getting data back. It's got, I'm just looking for the message part. Where are you? Yeah, we've got our operation. It's got an input. It's got an output. Just bear with me. This feels like it's not 100% generated from it. Unless I'm blind, I don't actually see the... What I'm looking for is the web parameter for the message. Yep, unless I'm missing it, I would have been expecting the hello input to have something for an MSG. Oh no, sorry, it's on the next slide, is it? Other schemas for it. Sorry, that's why. Okay, so yeah, I always forget. WSDL is even bigger than you expect it to be. So we've got our definitions for the service and the messages that can be sent. But then what is the actual way that these are structured? That gets referred off to another file or another part of the file where we say a hello world, sorry, hello response has a has a return type, and the hello incoming has a message as a parameter. So these get all split out into yet another part of the file. This is not the same as a DTD that we talked about before, but it is effectively the same of saying, how do we describe the contents of the input and the output messages? So all of this XML that I've sort of shown you on this slide that you don't need to know, you don't need to actually really understand the structure here necessarily and exactly what's going on, but this describes my 4 or 5 line Java file. And it describes it for the client, which is going to be written in PHP on the next slide. So we're halfway there. We've written our Java code. We've produced the WSDL and the WSDL schema for it. Then how does, say, a PHP code call functions on that Java code? We create a PHP SOAP client with the URI that was given to us of the hello service. And we set up the parameters that we want to call for the hello function, and we call the hello function. So this hello lines up to hello in Java land. MSG lines up to the tasty thing that you put on, no, MSG lines up to the parameter to the hello function that we had in our Java code. And that's all we do here, is we call it. It gets a little bit ugly, right? That we need to, we can get the last request information from it. So there's more debugging here than is strictly necessary. But if we want to try and get the response from calling hello function, we're getting a hit. Sorry, here, which is pretty handy. So it's not quite as simple as just calling the function all by itself. The return value doesn't go into an object here. It's stored inside the client, and then we've got to get it from the last client here. Just trying to see, do we actually show a screenshot of that? No, we don't. This would show the result of saying my message plus whatever the Java code had. My message returned from Java hello service code. So that's what it would print out. Here it is. Yeah. So as we've been banging on about, we make a SOAP request to invoke the code. So this is the envelope to body. There are no headers in this example because it doesn't need them, or I deleted them for screen space. So our body says we're calling the hello function with this message parameter. And then when the SOAP server in Java gives us our data back, it gives us a body again inside our envelope. And it gives us a hello response, which has a return value as a string. All right? Pretty straightforward. If you looked at these, this is the stuff that goes to the server and back from the server. if you took a snapshot of your application at this point, you would have no idea that this side came from PHP and this side came from Java. That's the point that we wanted to get to, is during the communication between these services, we didn't know, we can't actually tell what the programming language was on either side, because this is a standard communication method between the two. I like that comment, John. I agree. The point is, so, you know, other than what we're actually writing in the code, when we're looking at all this XML, which is a whole heap of structured data in a highly standardized environment that is SOAP, then yes, it looks unnecessary and it's very bloated, but it's very, what's the word here? Help me out in the chat here. What would you describe this as? So we could call it wholly unnecessary is one way of describing this. We could call it bloated, like I did, is another way of describing this. Has anyone in the chat got a positive word that they could use for this? I have one, but I just want to see. Technical. Wouldn't call that a positive word. Has anyone got a positive description for, you know, if we've got all this seemingly wholly unnecessary but not, and bloated communication between here, what would you describe it as? While I'm waiting for answers. Yeah, so kind of automatic. Yes. So that is one thing. Is there another that people have got? I'll answer Rudham there that absolutely. Remember, this is generated in the same way that an HTTP request and response are generated by your browser and your PHP. So the same sort of thing is happening in HTTP protocol. This is all generated. There we go. Aleander has said the word. He said the line, robust. It is. It's meant to be robust. Right. So one of the points I tried to make earlier was that because we're dealing with potentially two different programming languages, we're trying to make them interop. We don't want, and we don't have the luxury of compiling, checking. We're just going to end up with a million runtime errors unless we generate these very beautiful but bloated XML files that describe our interfaces to the nth degree, so that we can then get the wonder of hopefully compile time errors, or at least sensible errors in between, where if we've written the wrong kind of PHP code at this point, where this is a terrible example because PHP isn't type safe, but what happens if we accidentally sent a number here? Right? What's the Java code going to do when it receives that? It's going to crash. We don't want the Java code to crash. We want it to instead send a response that has a message saying that's an invalid request. And here's why. You gave an invalid request because we were expecting a message of type string. So it's wholly unnecessary, it's technical, it's bloated, but it is automatic and it is robust. It provides a little bit of type safety to a language that doesn't have it, PHP here, to some degree. It's still a runtime error, but at least we get a little bit of information along the way. But in terms of, if you think about what code you're actually writing, you do a little bit of boilerplate to set up the connection, you call the function and you get the response back. So that's 1, 2, 3, 4 lines. And on the Java side of things, you're writing a class as normal, but then you're adding on 1, 2, 3, 4 lines of annotation. And yeah, it expands out, right? So we're doing lots more annotation, but you're really just writing stuff in PHP and in Java, and the in-between stuff is sort of done for you by the SOAP library. And you'll see that in week 12. However, I still agree with John. If that makes sense. I'm allowed to agree with John and still say what I just said. So this is what it looks like in between. And yeah, the point that we're trying to make is, if you took a snapshot of this application at this point in time, of just looking at the requests and responses, this is fully language independent. We'll finish off with an easier example to consume because it's all in PHP and we can see the imagery of it, of what it looks like. In this particular example, we're not bothering with WSDL mode because we've got two programs both written in PHP and we don't always have to use WSDL mode. This is going to be closer to what you use in week 12. So both the client and the server are written in PHP. Yeah. So here's our server, right? Once again, it's a hello service. Same as that Java code, but written in a language that hopefully we're all understanding in this unit. I think we have to have an empty constructor, but here's our function, right? It's got its function name, it's got its parameter, and it returns the same thing as before. We set up our class like that. We don't even need annotations in PHP for this. It all just works. And then we do a little bit of boilerplate here to create our SOAP server to say where can we access it. I think that this URI ends up not being used for anything except for if we were using that that UDDI platform, but we have to set it, I think. We say what class are we actually exposing over the SOAP server, and this lines up hello service to hello service, and then we just turn it on and say start the SOAP server inside our PHP code. So pretty straightforward server-side code. Then on the client side, there's only a large amount of code here because I've decided to show you how you might actually do this with a form. So the entire thing from start to finish, you could grab this code. In fact, if you've got the slides, you can either do the week 12 tutorial or you can grab it from a GitHub gist here. But just focusing on what is actually happening here with the client, right? We've got our SOAP client object. It connects to the URI of the server, which is just another PHP file in this particular example. And we call the function. So we get our SOAP client again, we do a SOAP call, we say this is the function we want to call, here's the data that we want to send in, and here's us printing it out. That data that we send in is gotten from the form, so the form is a post request, but we didn't really need that for this slide. So the SOAP client is pretty straightforward as well. Here's what it looks like when run in the client, right? So the SOAP client is that we just get it printed out. There we go. Bob returned by the SOAP server for hello service. So there would have been us typing in the word Bob in the form before this. We spit out, if we really wanted to, and you'll do this in the tut, what did the envelope look like, just so that you can really see what's going on in there. And when I took this screenshot, I was far too lazy to even bother to word wrap this, apparently. But you've already seen on the previous slide what this looks like. Okay, what it looks like in transit. So this is a whole lot of work just to be able to make machines speak to each other using the SOAP protocol. Oh yeah, don't worry about this slide because this will all be covered in the actual tut. Remember I said that our dodgy self-signed SSL certificate would cause us problems. This is one of those examples where we have to allow the library to trust our dodgy certificate, and we had to add in some extra stuff. You'll do all this in the tut just fine, but if you were trying to follow along this example on your actual VM now instead of in a couple of weeks' time, you can use this slide to help yourself out there. Oh, an abrupt ending. We love that. So we have managed to finish nice and early, which is good. I don't want to start up on REST just yet because we will be covering that in the next lecture. REST is what we'll be doing in next week's tutorial as well. So we've got a bit of a straightforward tut this week where we're still looking at web security. But then, yeah, starting next week, we actually have a look at web services that you'll be doing for the assignment. So we just looked at SOAP then as a really robust way of doing remote code execution to some degree. But yeah, REST is not just something you'll be doing before class, but REST is what you're going to be doing for assignment 2, where you're going to be making a RESTful API. And that's what you'll be doing in the tut next as well. As I said, quiz 1 is on the end of next week. Your assignment's due at the end of this month, but you can expect the assignment 2 to come out, I would say, probably the week of assignment 1 being due, so that you might not be working on it straight away, but I want it there in front of you to look at, because there'll be some stuff to play with. I'm going to provide you with a base, not a base code, but I'll be providing you with a sample client that is trying to use your web service. So you're going to be making a web service, and I'm going to have a client that uses your web service. And the way that one way of testing and marking your assignment is going, okay, connect to John's VM and use that web service. And as long as he's written in his web service to the specification, the application will work and it'll be beautiful. And then I go test it on Alejandro's one, and then it doesn't work. And then no, it'll work perfectly as well. And that'll happen for everyone. We just connect it to each of the different web services and it'll work great. It'll be a bit more complicated than that, but yeah, that's the idea for assignment 2, is you'll be making a web service. Not in SOAP, but in REST. Okay, we're done. 20 minutes early or 10 minutes early, 12 minutes early, depending on your perspective. See you all in class this week. Remember to yell out on Discord if you get stuck on any of the assignment stuff. Yeah, see you everyone. Bye-bye.